Okay, hello guys. I think the brightness is okay. Okay, in D block elements, we have discussed some of the properties of transition elements, and we were doing last class. We were doing transition elements. Now we'll be solving a problem related to magnetic moment. So the question related is find the magnetic moment of scandium plus 2, titanium plus 2, vanadium plus 2, chromium plus 2, and so on and so forth. I've given some questions for you to solve. Okay, so basically in this you have to know at least this formula, that is magnetic moment mu is equals to root over n plus 2 for magneton, where n is equal to number of unpaired electrons. Okay, so if there is unpaired electron, then only magnetic moment will be there. However, if there is no unpaired electron, magnetic moment will not be there. So in this case, let's see for number 1, that is scandium. So scandium's atomic number. So students, at least you have to know the atomic numbers. So it may or may not be provided in the exam. So in this case I have provided. So scandium is atomic number 21. So in this case, what you have to do basically is you have to write the electronic configuration as 1s2, 2s2, 2p6. So that counts to 10. 3s2, 3p6, then 3d1, 4s2. So in this case, what do we have to actually remember is this, that 4s electrons are initially filled. So in some of the books, this may be in front, then 3d may be written later. Okay, so in this case, let's see now in the question it is scandium plus 3. Okay, sorry about the brightness. So in this case scandium is plus 3, so you rewrite the electronic configuration. So till this point, that is 1s2, 2s2, 2p6, 3s2, 3p6. okay, till this it will be same. Okay, so you can count, this is 10, this is 18. So scandium is plus 3, so that means you have to remove 3 electrons. So 3 electrons are being removed from 3d orbital and 4s orbital. So this will be now 3d0 and 4s0. So you can see it is 3p6. So that means here the number of electrons are paired. Okay, so in this case automatically your magnetic moment, that is mu, is equals to 0. You don't have to think of the calculation. Now similarly titanium is 22. So if you rewrite, it will be 3d2 then 4s2. okay, so in the question it is given titanium plus 2. okay, so that means you have to remove the electrons from 4s orbital. So it will be 3d2 then 4s 0. okay, sorry about this. Now in this case, after this what you have to do, you have to draw the orbital diagram. okay, orbital diagram. You don't have to draw for all the orbitals, you just need to draw for the last orbitals. So let's draw for 3d orbitals and 4s orbital. okay, so d orbitals will have 5 subshells, so you draw it. This is 3d, then it will be 4s. okay, 4s will have 1 suborbitals or subshells. So in this case you have 2 electrons, so 1, 2. okay, so you have basically 2 unpaired electrons. So you can write it here where n is 2. So therefore you can use the formula, that is magnetic moment mu is root over. So put the value of n, that is 2. So 2 plus 2 for magneton Then after that you have to do is calculate it. So it will be root over 2 into 10 to the 2 plus 2 is 4, so 4 magneton, then mu, so or mu will be equals to, so it is 8, so root over 8, or you can also write it as 2 root over 2. You can calculate this. I think this will be root over 2 will be around 1.4 magneton. Just calculate this, or mu will be equals to 8, so around 2.8 or 2.9 approximately. So this is the magnetic moment value of titanium plus 2. Similarly, you can solve for other elements as well. Okay, so if you have any confusion, let me know, and for the other elements you can try and let me know if there is any question or if there is any problem. Okay, so we'll stop it here for today, and please submit this by next week so that I can check it and correct it, and if there is any mistake or if there is any confusion, just let me know. Okay, thank you.